Section 10.3, parabolas. Y squared equals 10y plus 2x minus 19. In order to identify the features of this graph, we want to put it in the standard form for a parabola opening left or right. We know it's a parabola opening left or right because, first of all, we only have one letter to the second power. We have y to the second power, not x to the second power. If y is the variable to the second power, then the parabola is going to open left or right. And this is a standard form for a parabola opening left or right. It's y minus k quantity squared equals 4 times p times the quantity x minus h. So we want to try to match what our equation here to this form so we can identify the features and sketch the graph. We want a y minus k squared on the left side. So that means we want to put all the y terms together. So we want to subtract the 10y from both sides of the equal sign to get y squared minus 10y equals 2x minus 19. And then we want to make the left side into a perfect square. We take half the coefficient of y, half of 10 is 5, and square it. 5 squared is 25. And that's what we need to add to the left side to make that into a perfect square. In order to keep the equation equivalent, we also add 25 to the right side. Then we can factor the left side. Y times y is y squared. And we need two numbers to multiply to 25, add up to negative 10. And the numbers that work are negative 5 and negative 5. You can check with the FOIL method. Y times y is y squared. Outer product is negative 5y. Inner product is negative 5y. Combine those, you get negative 10y. Last times last, negative 5 times negative 5 is positive 25. We can add the two numerical terms on the right side. Negative 19 plus 25 is 6. So we have the quantity y minus 5 times the quantity y minus 5 equals 2x plus 6. We can write this more compactly using an exponent. This will be y minus 5 quantity squared equals 2x plus 6. And then we want to, so the left side is now in the form that we want it. We have y minus k squared. Now we want to work on the right side of the equal sign. Instead of a 2 here, we want a 4 times p. And also we want the x to be inside parentheses. So we need to work on that side of the equal sign. So we can first of all factor out the 2 from the x term from the right side. Factor out the coefficient of x. So we have 2 parentheses x plus 3. And then because we want a 4 there, we can multiply by 4 and divide by 4. So we can write 2 as 4 times 2 over 4. And 2/4 reduces to 1/2. And now you can pretty much stop there. It's pretty much the form we want it. If you want to exactly match the form, the form has a minus sign here instead of a plus sign. So if we put a double negative, that'll give us a minus sign. And now our form exactly matches, and we can identify the features and sketch the graph. Okay, so the vertex will be h comma k. So that's negative 3 comma 5. That's our vertex. Because of our y squared term, we're going to the focus is going to be either left or right, and because p is greater than 0, the focus will be to the right of the vertex. It'll be p is 1/2. It'll be 1/2 to the right of the vertex. And then if we go up, 2 times p is going to be 1. If we go up 1 and down 1 from the focus, that'll give us actually 2 points on the parabola in addition to the vertex. The line segment connecting these 2 points is called the lattice rectum. The line going through the vertex and the focus is called the axis of symmetry. There's another line that's important for some applications called the directrix. And again, because the y squared term, we're going left or right. Because p is greater than 0, the directrix is going to be to the left, and it'll be p equal 1/2 to the left of the vertex. Okay, so here's the parabola. The vertex is 3 to the left, up 5. That's our vertex. And then the focus from the vertex, we're going 1/2 to the right. That's our focus. And then from the focus, we're going up 1 and down 1 to get actual points on the parabola in addition to the vertex. The line connecting those 2 points is the lattice rectum. The line through the focus and the vertex is the axis of symmetry. It's called the axis of symmetry because the left side is kind of the mirror image of or the top side is the mirror image of the bottom side here. And this other line, the directrix, is 1/2 to the left of the vertex. So that's our, and then we want to connect the dots. Once we have the points there, we connect the dots and extend it to get the graph of our parabola. And that concludes this presentation.